Hello everyone, this is BronyCalc. You guys know the drill. Third pair of the ARML 2017 individual round. Done in competition time of 10 minutes or less, starting now. Problem 5. Given that 2 to the negative 3/2 plus 2 cos theta, I'll write that down up here. Negative 3/2 plus 2 cos theta plus 1 equals 2 to the 1/4 plus cos theta. Find cos 2 theta. So you might look at this and say, powers of 2, huh? 1 plus 1 equals 2. And you may or may not be right, but we should be a little more careful and rigorous about this. We don't want to just jump on our first instinct all the time. So let's look at this. I see here we have cos theta and 2 cos theta. So if we could get this 2 out somehow, I'll maybe multiply this by a constant, express this in terms of 2 times something with cos theta in it. That would become a square, and we would have a quadratic. So let's try u equals 2 to the 1/4 plus cos theta. What does this make this? We get 2 to the negative 3/2 plus 2 cos theta. And then, sorry, that was a little messy, 3/2. Then I can factor out the 2 right now, just so we can see a little better. Negative 3/4 plus cos theta. Well, we have negative 3/4 here. We have 1/4 here. So we have so this is just this minus 1. So we have 2 to our random stuff with cos theta in it minus 1 is equal to 2 to the 2 squiggle minus 2, which is just 2 squiggle over 4. Now 2 to the 2 squiggle, as we showed back in problem 1, is just this squared. So we have 2 to the squiggle, this is squiggle here, 1/4 plus cos theta. So we have u squared over 4 is this. So now we can write u squared over 4 plus 1 equals u. Then we can go with u squared over 4 minus u plus 1 equals 0, or u squared minus 4u plus 4 equals 0. In other words, u minus 2 squared equals 0, or u equals 2, and this is 1. So this was 2 and this was 1. Our first instinct was right, but again, it's important to check to make sure. So now I know that this is 2, which means 1/4 plus cos theta is 1, or cos theta is equal to 3/4. Cool. So now we need to find cos 2 theta. We can use our double angle formula, 2 cos squared theta minus 1. We know cos theta is 3/4, so we have 2 times 9/16 minus 1 equals 18/16 minus 16/16 equals 2/16, or 1/8. And that is indeed the answer we are looking for, so we are done at just under the 4-minute mark. So now on to problem 6. Diagonal of a 2017 gun is chosen at random. Find the probability the chosen diagonal is larger than the median length of all the diagonals. So we need to find out how many possible lengths there are and how many there are of each. So let's just start with the simplest one. And we have vertices that are 2 apart. Now notice, vertices that are 2 apart in a 2017 gun is the same as vertices that are 2015 apart. I'm not going to draw 2015 because then we would be well past the 10-minute mark and every 10-minute mark to the end of time. So we know that 2 and 2015 are the same. That's important, we'll keep that in mind. And we want to find a way to count these. Well, how about we count the number of starts? I'm going to find start as the one that is counterclockwise. And if we have the counterclockwise vertex different from clockwise vertex, we can really just do any of them. So we have 2017 possible, I'm going to call this 2 diagonals. Then we have 3 diagonals. Note that 3 diagonals are the same as 2014 diagonals again, and just all the sides adding up and everything. And once again, we set counterclockwise 2017. 2017, 3 diagonals. And we can keep going like this. So we want to find out where we're going to end. We'll notice that when this went up by 1, this went down by 1. So eventually they're going to reach a point where they're equal or almost equal. So about half of 2017 is about 1008, 1009. So 1008, 1009. Again, not drawing it. Just going to draw circle, circle. So we notice that these add up to 2017. And if we were going for, we have 1009, 1008. So those would be the same. So once again, this is going to be 2017 in 1008 diagonals. And then that's all the diagonals we have. Now we can check really quick to make sure these are all 2017 by noting when wouldn't it be 2017. Well, the only time when it wouldn't be 2017 is when, if we were to take is when in a diagonal, if we take this to be counterclockwise 1 or this to be counterclockwise 1, it's the same diagonal. But that only happens in evens when they're directly across from each other, when they're like diameters of the polygon, we're going to say. So we don't need to worry about that, since we have an odd number of vertices. So we've got 1007 possible values, because we don't have one diagonal, so you can't include edges. So, and there are 2017 of each, so we can just ignore that. There's equal numbers, so really we're just choosing which length we want. So since there are 1007, we can break this up into the median here, 503 here, 503 here. We get 503 over 1007, which is the right answer. And we did that in only about 7.5 minutes. I remember at the UNLV location, after this pair, people were joking that this should have been 3 or 4, or even that this should have been 1 and 2, which is fair for number 6, but I feel like number 5 was actually a pretty fun problem. Because if you didn't guess it right away, or you just want to be careful, it took a little bit longer. I noticed a lot of people were using substitutions like that involved the 4th root of 2, which gets really, really ugly. So in my opinion, including that 1/4 that showed up at the beginning in our substitution just got rid of a lot of ugly numbers you'll see in a lot of our solutions. Anyways, that concludes this pair, so don't forget to like, comment, subscribe, maybe ring the notification bell, share this with friends you think would be interested in it. And I will see you soon with the 4th pair. Peace.